Okay, let's get right into it. Welcome to today's explainer. We're looking at a fantastic blog post by David Kay over at Pour Filtration, and it tackles something literally every plant manager or process engineer deals with a like-for-like filter replacement. You know the drill, right? A filter blocks up. You pull out the exact same part number and you slap it back in. But here's the thing. This status quo reflex might actually be costing you way more time and money than you realize. So let's rethink it. Here's the quick roadmap for our engineering detective story today. First, we'll look at the replacement trap. Then we'll dive into a real water treatment case study after that. Why filter media matters, reviewing the whole process. And finally, your engineering checklist. Let's hit it. Section 1, the replacement trap. Escaping the like-for-like mindset. So it's totally human nature, right? You look at a blocked cartridge that's hit the end of its life and think, well, if the existing filter has been doing its job, why change it? It's the most natural assumption in maintenance. You just want to get the system back online. But here's the catch. Your industrial processes, they're basically never static. Production demands ramp up. Incoming water quality fluctuates wildly, and your operating conditions are probably way different now than they were the day the system was first commissioned. Notice this stark contrast in mindsets. The standard industry approach is usually just, hey, which replacement cartridge fits this housing? That's literally just plugging a hole. It's treating a symptom. But the expert consultative approach, the one we want to cultivate, asks, is this filter media still the most suitable? That is a massive shift. It moves us from just barely maintaining the status quo to actually digging down, finding the root cause, and optimizing the whole system. Which brings us to section 2, a water treatment case study uncovering the culprit. Okay, so picture this. A customer in the water treatment sector reached out with what seemed like a super straightforward problem. Their pleated polypropylene depth filters were just dying way too fast because their application had a really high particulate loading. The filters were blocking prematurely. We're talking constant cartridge changes, spiked maintenance time, and ballooning consumable costs. Naturally, their initial request was just to buy more of the exact same cartridges. Now, from a supply standpoint, you could easily just send them a quote and call it a day. But hey, what a missed opportunity for improvement that would be. Because instead of just reordering a part number, you've got to put on your process engineer hat and ask, what are the changing variables in the system? You have to look way past the physical dimensions of the cartridge. You really have to play detective here before recommending anything. You need to build out the whole picture. What is the actual water source? What exact contaminants are we trying to yank out of there? Has the process or the production volume changed recently? What are the current flow rates and pressures? Asking these hyper-specific questions reveals completely hidden underlying issues and opportunities. Stuff you'd totally miss if you were only focused on a like-for-like replacement. Moving on to section 3, why filter media matters. The solution revealed. So not all depth filter cartridges are built the same, right? Understanding the science here is how you actually solve the problem. Polypropylene media is an absolute workhorse, excellent and reliable for lots of standard applications. But as this specific case study proved, it's not always your best friend for heavy contaminant loading. Then you look at glass fiber media. Glass fiber inherently has a much higher dirt holding capacity. So for the heavy particulate loading, this facility was getting hit with glass fiber was scientifically the far superior choice, and the results were completely off the charts by simply switching the media type. This customer saw a massive 3 times increase in cartridge service life. 3 times. They went from endlessly swapping blocked filters to running a highly optimized, smooth system that is a staggering return on investment that slashes maintenance frequency right down. Now, pay close attention to this, because it's basically the core takeaway of our whole explainer today. The physical filter housing didn't change. The overall water treatment process didn't change. Even the micron reading stayed exactly the same, literally. Only the filter media changed. It's wild how such relatively small, highly targeted engineering tweaks can deliver these huge operational wins without requiring some massive, expensive system overhaul. Let's zoom out a bit for section 4, reviewing the whole process. Looking upstream and downstream. Changing the media was the silver bullet for that case study, but we absolutely have to look at the entire integrated system in a lot of water treatment applications. You have a filtration train where each part protects the next. Think of it like a chain of bodyguards. First, you might have basket strainers pulling out the big, raw debris. Next, bag filters step up to reduce the heavy particulate loading. Then, our depth filters take out the suspended solids to protect the super-sensitive equipment. And finally, membrane filters handle the absolute final microbiological or particulate control. Every single stage has a very specific job to do because everything is so incredibly interconnected. A blocked cartridge is honestly often just a symptom of what's going on somewhere else. If your depth filter is dying constantly, maybe it's because your bag filters upstream are failing or the incoming water quality completely tanked. Evaluating the entire filtration train ensures you're fixing the root cause rather than just slapping a plaster on a symptom over and over again. Oh, and we definitely can't forget about your maintenance procedures. A lot of processes incorporate clean-in-place SIP or steam-in-place SIP protocols. These are serious, routine industrial cleaning cycles using harsh chemicals and extreme temperatures. A filter media might have incredible dirt-holding capacity, but if it literally melts or degrades during a SIP cycle, totally useless to you. Chemical and temperature compatibility are just as crucial as raw filtration performance. When you're looking at the whole picture, okay, let's wrap this up with highly actionable takeaways. In Section 5, your engineering checklist. A proactive approach before you blindly sign off on that next purchase order for a like-for-like replacement. Run through this punchy checklist with your team. Have there been any process changes since day one? Have production volumes spiked? Did the incoming water quality shift? Are you dealing with a different contaminant profile now, or your SIP or SIP regimes dictating material compatibility? And do you need better upstream protection for your downstream filters? Going from reactive firefighting to this kind of proactive evaluation is exactly where real efficiency is born. To tie this entire philosophy together, I absolutely love this quote from the original author of our source, David K. at Pour Filtration. He says every successful project starts with understanding the process, not simply replacing the filter. I think that just perfectly hits the nail on the head. It shows exactly why you want a consultative partner, not just a parts supplier. And that brings us to the end of our explainer today. I want to leave you with one big question to chew on. Is your facility actually running as efficiently as it could be? Or are you just stuck treating the symptoms next time a filter blocks? Don't just reach for the same box. Take a step back, look at the big picture, and ask those hard process questions. The answers might completely transform your operations. Thanks for being here, and don't forget to get in touch with Pour Filtration for help with your filtration requirements.